Okay, we're gonna go ahead and get started, and actually let's give it a few seconds for people to log back in. Okay, I'm sorry. It looks like there's some buffering going on. I do apologize. If you can't hear me though, please let me know. You can type it into the live chat bar. So. Sorry, we're dropping in and out. Hopefully that will pass. Okay, so we're gonna talk this morning about, continue talking about lines, and going to work a problem that we didn't have time to work from the previous day's lecture. It asks us to graph a line given its equation in what's called standard form. So let me explain what the standard form of a line, the equation of a line is. So all standard form means is that you have all the variable terms on one side and any constant terms on the other. So it always looks like ax plus by equals c. A, b, and c could be any numbers. So for example here, we have a is our -2, b is 1 because there's a 1 that's not written being multiplied in front of the y, and then c is equal to +2. All right, but all you really need to know is that all the x and y term are on one side and the constant on the other. So this is not the best form to have a line in if you want to graph it. Remember, when we have the line in the form y equals mx plus b, which was called the slope-intercept form, y equals mx plus b, we talked about graphing a line in that form. Do you remember what the m and the b stood for? Anybody want to type into the chat bar what the m and the b stood for? Or one of them? I'll give you an extra bonus point. Oh, good. That's right. M is for slope and B is for y-intercept. Okay, so it would be nice if this equation that we're looking at right now, if we had it in that form. But really, getting it in that form, all that means is getting y by itself. So let's go ahead and move that 2x over to the other side. We're going to add the opposite of that term over to the other side. And so the slope-intercept form of the equation of this line is going to be y equals, because negative 2x and positive 2x cancel out. And then we could write 2 plus 2x, but usually we write the x term first. So I'm going to write it that way, 2x plus 2. So we have y equals 2x plus 2. So that means that our slope m is 2 and our y-intercept b is also 2. So let's go ahead and graph y equals 2x plus 2 using that information. So here at home, I hope that you have paper out and that you're drawing the graph, because drawing a graph on paper is a different skill than drawing it on, say, your Alex internet account, or possibly selecting a multiple choice answer of a graph. It's a very different experience to actually draw it from scratch. I encourage you to do that. All right, so we have the x-axis I'm going to label here, and we don't need very large numbers because we have 2's in our equation, so maybe that's 1, 2, 3. Remember, on the y-axis, going up is positive, and on the x-axis, going to the right is positive, and going to the left is negative. Okay, so I'm going to plot, well, what I'm going to do first is identify my y-intercept, and the y-intercept, the y-coordinate of the y-intercept is 2. So we know that 0, 2 is a point on our graph, and I can see that the buffering is pretty bad right now. Sorry, guys. Hoping it resolves itself. So 0, 2 you can think of as a starting point, but then we also want to use the fact that our slope is equal to 2, but I'm going to think of it as 2 over 1 so I can think of the rise over run. Now, since 2 is positive, and you get a positive by dividing a positive by a positive or a negative by a negative, you have the option of thinking of this slope as 2 over 1 or negative 2 over negative 1. And that's going to give you 2 different points depending on which option you choose, but they'll both be points on the same line. So let's go to our starting point, 0, 2. Okay, here's 0, 2. All right, now let's suppose that I choose to think of my slope as positive 2 over positive 1. That's rise over run, and both of these are going to be positive, so the 2 is telling us to go up 2, and the 1 is telling us to go to the right 1. So if I go up 2 and to the right 1, then I'm going to be located here at the point 1, 4. Now, another person might have, most people would have done the positive, I'm sure, but it is also possible to think of it as negative 2 divided by negative 1. And so you can think of it as going down 2 and to the left 1. And so if you go down 2 and to the left 1, you're going to be at the point negative 1, 0. Notice that these lines, now they look a little off because you know I'm graphing this by hand, but basically they look like they're collinear, they're on the same line. So let's go ahead and connect the dots. Takes me a while to do this on the paper here. Oh, actually that one's pretty good. All right, so make sure that when you're drawing your graph of your line that you connect the dots. I want to see the line drawn. I want to see the coordinates for each point labeled on the line. So this is how you graph a line when you have the slope-intercept form. You plot the y-intercept first, that's your starting point, and then you use rise over run and your slope to get another point, at least one other point. All right, as we go along, if you have any questions, feel free to type them into the chat bar. I'm going to move on now to the next problem. Oh, before I do, I just want to point out, I want to remind you about a formula that we used in class last time, which is a different way to find slope. Just now we found the slope using slope-intercept form. We said that the coefficient of the x there too was the slope. But there was another way that we discussed on the first day for finding slope, which is to use the formula y2 minus y1 over x2 minus x1. So if you use this technique, we now have 2 points and we could plug into that formula, and I just want to show you that I still get the slope of 2. So for example, if we let this be our x1 y1 and this be our x2 y2, we would have 4 minus 2 over 1 minus 0, which turns out to be 2 over 1, or 2. So you still have the same slope, finding the slope of the line by looking at 2 of its points. All right, so a lot of times people, when I say what's the slope formula, they think slope-intercept form. It depends on if I'm asking you for the slope of a line given 2 points, or if I'm asking you to find the slope given the equation of the line, which one we're looking at. Okay, let's go ahead and scroll down now. And remember, you have access to this in your OneNote file. There's a link in D2L. Okay, so continuing with objective 2, we are going to look at a question from Alex that I get a lot of emails about. I just want to give you a heads up on how to work this type of problem. So in this case, they say the points 4r and 8, -2 lie on a line that has a slope of -5/4, and we're supposed to find the missing coordinate r. So instead of giving you the 2 complete pairs of points, they're giving you a missing coordinate, and then they're giving you the slope. So you still plug into the formula slope equals y2 minus y1 over x2 minus x1, the difference in the x coordinates over the difference in the y coordinates. But you're going to have to plug in and solve an equation. Let me show you what I mean. So we are going to say that this is our, let's let this be our x1, y1, and this will be our x2, y2, and of course the slope is our m. So we have -5/4 equals, and then we're going to do y2, which is -2, minus y1, which is r. I'm just waiting for the stream to improve here. Okay. All right, and then we're going to plug in x2 minus x1, so that's going to be 8 minus 4. And then what that gives us is -5/4 equals -2 minus r over 4. Now, there's several ways. This is a linear equation. We're just going to try to get r by itself, but it does have fractions in it. And there are a couple of ways that people approach this problem, and I'm going to show you 2 ways because Alex does it one way, and I want to make sure you understand the other way as well. So what we're going to do is, one way is you look at the denominators on both sides of the equation, and you multiply by the least common denominator. In this case, both the denominators are the same, so that's easy enough. We're going to just multiply both sides by 4. And then we're going to see that when you multiply a fraction by a whole number and you think of it as being over 1, you multiply straight across. And if you want to, you can reduce diagonally. So 4 goes into 4 once, 4 goes into 4 once. So I'm going to multiply across now, and we're going to have 1 times -5 is -5. 1 times 1 is 1, but we don't need to write divided by 1. That doesn't change anything. So what's happened is that the 4 cancels with the other 4, and we're just left with the negative 5 from the numerator. The same thing's going to happen on the other side. So we're going to have negative 2 minus r on the right. Okay, now this looks much easier, right? No more denominators. And now we want to get the numbers to one side and the variables to the other. So I'm going to add 2 to both sides. And when you add 2 to both sides, you're going to get negative 3 equals negative r. Okay, so now r isn't quite by itself yet. We still need to get rid of that negative. You can do that by multiplying or dividing both sides by negative 1. So that means that r must be 3. So we found the missing coordinate. Remember, the problem was find the coordinate that yields the given slope. The points 4r and 8, negative 2 lie on a line with a slope of negative 5/4. We just found that r must have been 3. So that's a type of problem that'll pop up in your ALEKS, and I wanted you to see it because it's a little bit unusual. Let me solve this equation one other way. Let's go back to the step where we had negative 5/4 equals negative 2 minus r over 4. So when you have one fraction equal to one fraction, there is a method, this is called cross multiplying, because this equation is actually a proportion when you just have one fraction equal to one fraction. And so you may have seen this trick here where you multiply the product of the means equals the product of the extremes. In other words, you cross multiply. So negative 5 times 4 would be on one side, and then 4 times negative 2 minus r would be on the other. Make sure to use parentheses because you're going to need to distribute. And then we're going to say negative 20, distributing the 4 through the parentheses would give us negative 8 minus 4r. You still want to get the numbers to one side and variables to the other, so I'm going to add 8 to both sides in this case. So we're going to get negative 12 equals, and I can see we're dropping frames again, I'm sorry guys, negative 4r. And now we're going to divide both sides by negative 4. Okay, and so dividing negative 12 by negative 4 gives us positive 3 again. So 3 equals r. All right, so whether you treat this whether you solve this equation by multiplying both sides by the common denominator or by using cross multiplication to solve a proportion, you should come to the same conclusion. All right. Now let's go back and talk about equations of lines again. So this time we are supposed to be finding the slope and y-intercept of the line given it's in the form ax plus by equals c. Do you remember what we just said was the name of this form of a line? Ax plus by equals c. Anyone want to type that into the chat bar? Anybody know what that form of the line? It's not slope-intercept, it's the other one. What did we call it? You're gonna type in, nobody's gonna be brave and type it in? I know there's a little bit of a delay between when I ask the question and when you hear it, so I'm trying to give you extra time. Standard form, thank you, good job. All right, so I'm gonna write that down. So we have standard form. Okay, but is that the best form to use to get the slope and y-intercept? No. So here we have our equation in standard form. The x and y terms are on one side. But we want to find the slope and the y-intercept, so it would really be better if we could get it into slope-intercept form. Y equals mx plus b. So that just means getting y by itself, right? So the first step is always the same when you do this. You always are going to want to move the x term over to the other side. So let's go ahead and do that. So to move an entire term, terms are things separated by plus or minus, you're going to have to add or subtract depending on the sign of the term. In this case, the term was negative, so we need to add, and that cancels out, and we get 4y equals 12x minus 4. You could write negative 4 plus 12x, but that's not really the form we want. We want mx plus b, so we want the x term first. All right, the next thing we have to do in this case is there happens to be a coefficient in front of the y. Coefficient is just the number being multiplied by the y. Since it's being multiplied, you will always have to divide to get rid of it. And here's the thing you really need to pay attention to. A common error is to just divide one of the terms by the 4, but we're dividing the whole side by 4, so we need to divide each term by 4. Oops. I swear. Okay. All right, so let's go ahead then and divide 4 by 4, we get 1, so y is by itself. Divide 12 by 4, we get 3, so we have 3x. Dividing negative 4 by positive 4, we get negative 1. So this is the slope-intercept form of that same line. Now, they didn't ask us to get slope-intercept form, but they did ask us to identify the slope and the y-intercept, so that's why this is useful to us. All right, so the slope in this case, m, would be 3, and the y-intercept, b, would be negative 1. I believe that's how Alex allows you to type it in, but just keep in mind that it really is a pair of coordinates. That is a point, 0, negative 1. And you can see if you plugged 0 in for x, you would get negative 1 for y. Sorry, I'm just checking on something here. Don't know why that output's so bad today. Seems like it's just random sometimes. Some days are good and some days are bad. Okay, so let's go ahead and move on to another question. By the way, if you have any questions, you can always type them into the live chat bar. If you're having trouble watching this because of the buffering, you can always go back, and within 24 hours I'll have the link to the recorded version posted, and then it should be better. Okay, so the next thing we're going to talk about is something about how different slopes are related. So you've probably seen in the past that you have sometimes pairs of lines that are called parallel, and parallel lines have the same slope. So parallel lines you may also recognize because they never meet. So if you look at their graphs, they're never going to bump into each other because they're both headed in the same direction. And the reason is because they have the same slope. Okay, so if this one has, say, a slope of 1, then this one also has a slope of 1, then you know they're parallel. Another relationship you can have between the slopes of two lines is you could have them be perpendicular lines. Perpendicular lines meet at a right angle, at a 90-degree angle. And there's a very special relationship that causes that to happen, and that is that if you, let's say this is line 1 and this is line 2, if you multiply line 1's slope, so, ooh, I better call that M1. So if you multiply the slope of line 1 times the slope of line 2, you get -1. In other words, think about what types of numbers that you can multiply together and they'll always give you a -1. They have to be reciprocals of each other to multiply to give you a 1. They have to be opposite signs to give you a -1. So M1 and M2 we say are opposite reciprocals. As an example of opposite reciprocals, M1 could be 1/2, and if you flip that over and negate it, M2 would be -2 over, or just -2. So when you're looking to see if slopes are of lines are perpendicular, you're going to check to see if they're opposite reciprocals of each other. All right, so with that in mind, let's go ahead and work this next problem. There we go. I'm going to shrink this a little. No, maybe I better not. Okay, so it says finding slopes of lines parallel and perpendicular to a given line that's given to you in the form ax plus by equals c, in other words, standard form. So we're given this line, -3x minus 2y equals 4. And we're asked to, what is the slope of a line perpendicular to this line, and what is the slope of a line parallel to this line? Well, in order to answer those questions, we need to know the slope of the original line. How do we identify the slope of -3x minus 2y equals 4? Well, it would be better if it was in slope-intercept form, right? So solving for y. So we're going to solve for y to get slope-intercept form. Okay, so in this case, remember what the first step is? Try it at home real quick. How do you get y by itself in this equation? Think about what you would do first. Okay, if you said you would move the 3x over by adding 3x to both sides, you are correct. So I'm going to move this 3x over, and that's going to give me -2y equals 3x plus 4. And then we're going to divide by the coefficient of y. It's the same steps every time when you get an equation from standard form into slope-intercept form. So I'm going to divide by -2. Remember that we need to divide each part by -2 on the right. So we're going to have y equals 3 divided by -2. Don't try to write that as a decimal. Just write -3/2. To get a perpendicular line, your slopes must multiply to give you -1. In other words, the slopes need to be opposite reciprocals in order for the lines to be perpendicular. So you have to flip it over and change the sign. So let's go back down to the slope that we found. We found a slope of -3/2. So for part A, to get perpendicular slope, we would have to flip it over, which would be 2/3, to have perpendicular lines. Now part B, that's the hard part. Part B is the easy part, because to get a slope of a parallel line, it's the same slope. So for a parallel line, you're just going to use the slope -3/2. So there's going to be some problems in ALEKS where they ask you to find slopes that are parallel or perpendicular. All right, so the last thing is we're going to look at 3 different lines, and we're going to determine which pairs are parallel, which pairs are perpendicular, and which pairs are neither. And so in other words, we have line 1, 2, and 3. We're going to compare line 1 to line 2, line 1 to line 3, and line 2 to line 3. And we're going to see how they compare. All right, so line 3 is luckily already written in slope-intercept form, but the other 2 are not quite there, so we're going to have to do a little rearranging to identify the slope. Don't make the mistake of looking at the coefficient of x and forgetting that y is not by itself yet, and thinking that, for example, line 1 has a slope of -5, when in fact it does not. We can't identify the slope until we rearrange the equation. How do we need to rearrange the equation of line 1? Well, it almost has y by itself, but we have to divide by 2 to get it completely by itself. So that would mean we have y equals -5/2 x plus 5/2. So the slope of line 1, which I'm going to call M1, is equal to -5/2. All right, now to rearrange line 2, it takes a couple more steps because we have the x over on the left, so I'm going to have to subtract 4x from both sides. So that means that we're going to have -10y equals, well, let's write it as -4x plus 6. Now we're going to divide both sides by -10. And when I do that, I'm going to reduce a bit too. I'm not going to leave it as, for example, 4/10, but reduce it. So this is going to be y equals, instead of 4/10 x, I'm going to write it as 2/5 x. And remember, that was a 6, not a b. Sorry, my b's and my 6's look alike. All right, -6/10 reduces to -3/5. So slope 2 is +2/5. And then over here, line 3, we have slope 3 is already visible because it's already in slope-intercept form. That's going to be -5/2. All right, so let's go and do our comparing now. So line 1 and line 2. Line 1 had a slope of -5/2. Line 2 had a slope of 2/5. So the first thing you ask yourself is it parallel? No, because they're not the same slope. Then you ask yourself, is it perpendicular? There are 2 ways to check. You can either look at them and just say, are they opposite reciprocals? Well, they're opposite because one is negative and one's positive, and they're reciprocals because they're flipped over. So yes, they're perpendicular. Or another way to do it, again, is to multiply -2/5 times -5/2 times +2/5, and see that that gives you a -1, and that tells you that line 1 and line 2 are perpendicular. All right, if they're perpendicular, then neither is not an answer. Okay, let's look at line 1 and line 3. So line 1 had a slope of -5/2 and line 3 has a slope of -5/2. They're the same slope, so they're parallel. If they're parallel, they can't be perpendicular or neither. And then we're going to look at line 2 and line 3. Line 2 is a slope of 2/5. Line 3 is -5/2. These are opposite reciprocals again, just like we had with line 1 and line 2. So those turn out to be perpendicular. So they're not parallel or neither. All right, so that answers that question, but I want to give you a little bit of a heads up. In ALEKS, often they will give you one of the lines with, say, what if we had a line 4? And what if line 4 had a slope of 5/2? Okay, so slope 4, 5/2. Then let's compare line 1 and line 4. Okay, so line 1 had a slope of -5/2. And line 4 has a slope of +5/2. All right, these are not equal, so they're not parallel, but they're also not opposite reciprocals. They're opposites, but they're not opposite reciprocals. So the answer to that one would be neither. Similarly, let's compare line 4 and line 2. So line 2 had a slope of 2/5. And line 4 had a slope of 5/2. They're not equal, so they're not parallel. Are they perpendicular? A lot of times people think they are because they're flipped over, but remember they have to also have opposite signs, which they don't. If you multiply these two together, you get 1, not -1. So the answer here again would be neither. So as ALEKS regenerates different questions of this format, you're going to see sometimes you do get neither as an answer, and you have to watch out for that because that's usually where people get tripped up. All right, that's all for today. Thank you for logging into the live chat. I hope you're having a good first week. I do want to remind you that you should be working in ALEKS on Objective 1 right now. The deadline is coming up fast because you are in an 8-week class, so more than an objective a week, generally speaking, like an objective and a half, because we have 12 objectives to get through in 8 weeks. So hopefully you've taken your initial knowledge check and you're ready to go. But if you are having any trouble, you should contact me right away. Remember, you can find me on Skype by downloading the Skype app and looking up qhearn.broward.edu@gmail.com. Okay, and it's really, really critical to your success in the class that we get you going on ALEKS quickly. The first objective a lot of times goes quickly for people, but not always. And even if it does go quickly, you want to move on to the next objective because eventually you're going to bump into one that takes you a little longer. Remember, everybody has a different background in this class. So anyway, you guys have a great weekend, and I look forward to hearing from you either via email or via Skype if you need anything at all. Oh, and by the way, if you're watching the recorded version of this, don't forget to post a comment so that you can get points too. And it would help too if you give it a thumbs up if it was helpful, because that helps other students to find the video.